College of Medicine, and Professor Papanicolaou has many publications, over 300, in the cerebral organization of Eiger function, pre-surgical functional brain mapping, and also he published many books, so he's very well known in this research field. And Professor Papanicolaou is going to present a lecture on the possible outputs of human brains and intelligent machines. So, thank you very much.
All right, thank you. I'm about to argue against two claims concerning the capabilities of AI. Both are claims that have been repeatedly made by AI proponents, and I don't know how much of a concern they are to you, but they are of concern to the general public. The claims are first that AI machines, let's call them robots, can acquire consciousness. And second, that the robots could revolt against their human makers. I will therefore try to show that both claims are false for any version of AI, present or future, as long as it entails processing of signals, regardless of whether the signals are digital or analog, and irrespective of the kind of architecture of the AI systems. But to understand my arguments, we need to be clear about a couple of facts, simple facts. From a very pragmatic point of view, we can place all things that humans do, all the phenomena that our nature generates, into two clearly distinct categories. We can call the contents of the one category behaviors, and of the other category phenomenal experiences. With behaviors, we are very familiar. We know them through our senses. They are public, and they can be made public, and they are quantifiable and measurable. They consist of patterns of movements of body parts, with each pattern standing for a specific answer to the human organism, to external or internal influences. Some such patterns are generated by our lips, the tongue, the vocal cords, and the diaphragm, and these are the words we speak. Other patterns that we create with our hands and which we call gestures express our attitudes. Still others, mainly facial gestures, express our sentiments, our emotions. All these are public, overt, readily observable, and quantifiable, and measurable. But there are other behavioral responses that, although they are not public, they can be made public. For example, responses like changes in the blood pressure, in the heart rate, in the diameter of the pupil, but also the release of hormones in the bloodstream, the peristaltic movements of the stomach, the contractions of the diaphragm, and even changes in the electrical activity of individual brain cells. All these can be made public, therefore observable. In fact, sooner or later, we will be able to see in real time and in vivo the exchange of electrochemical signals among neurons in the functioning brain. Actually, we have begun to do so through functional neuroimaging. fMRI, I'm sure you have heard of fMRI, PET, magnetoencephalography, etc. Sometimes we call all the behavioral phenomena I just mentioned discriminant responses because they are not random, but they discriminate among internal and external stimuli and situations. Now, complex series or constellations of such responses create behavior, such as verbal outputs, verbal responses to questions, hormonal and visceral changes that are part of our emotional behavior, but also the activities we call composition of poems and of musical pieces, and the painting of pictures, of computing solutions to mathematical problems, of drawing blueprints for skyscrapers, of diagnosing diseases, or of predicting the stock market, and so many other observable and measurable public activities. This is then the first category of phenomena that the human organism generates. And for some years now, it has become abundantly clear to almost everybody that AI can match and in many cases surpass the human mind in generating and outputting behavior of the kinds I just enumerated. But as I mentioned before, behavior is not the only category of phenomena that human beings generate. Most importantly, human beings are capable of subjective experiences which are often, not always, but often, expressed by the behaviors or by the discriminant responses I enumerated above. Experiences are categorically different from behaviors. There is one thing to speak a word and another to experience the meaning of the word. It is one thing to have a pattern of brain signals that are quite different, and quite another thing to have the experience which corresponds to the measurable pattern of brain activity. I'm not saying that the two kinds of phenomena, the experiences and the behaviors, are unrelated. I'm saying that they are different. In what sense different? Well, the brain activity, is considered by many to be the cause and the experience the effect. But there is still a more fundamental distinction than that of causes and effects. Unlike behaviors, including patterns of brain signals, the experiences are neither public nor potentially public. Experiences are only known or felt by the subject that has them. Again, a spoken word is one thing, whereas the felt meaning of this, or the significance of the word, is an entirely different phenomenon. A felt pain is one phenomenon, and the pattern of neuronal activity that corresponds to it or causes it is categorically different phenomenon. These experiences come in several varieties. First, there are the experiences called sensations. For example, sensations of red, of lines, of light patches, of hot and cold, of itches, pressures, and so on. Sensations appear to form the basis of all other varieties of experience. Then there are the feelings, like the feeling of pain, of thirst, or of lust, that are based on sensations. Then, based on simple feelings, are the sentiments or the emotions, like those of joy, of sadness, of exaltation, and of course then are the thoughts, or rather the meaning of thoughts, and the hierarchies of our values, aspirations, and intentions. I hope you realize that it is absurd to try to see and measure someone else's or even your own pain. You may certainly measure any and all the behaviors or the discriminant responses that are associated with pain. You could certainly record the exclamations, the verbal report of pain, and how high it seems on a particular scale. You could also record the chemical changes in the body, the electrical impulses in nerve fibers, and even the pattern of the brain activity associated with pain, but never the experience of pain or of any other experience whatsoever in itself. The body and the brain activity constitute one kind of phenomena, and the experiences that, according to many people, are the results of that activity are phenomena of an entirely different kind, of a fundamentally or categorically different order. Please note that this is not a hypothesis. It is a hard and undeniable fact. And those that fail to understand that simple and obvious fact will always be confused and talk nonsense when it comes to specifying the limits and the powers of AI. Therefore, you may want to keep this fundamental matter of fact in mind when we try to answer the question as to whether AI-empowered robots can generate experience, whether, that is, they can become conscious. Now, to claim that present-day AI systems can generate not only behavior but also experience, or that some robots made today are conscious in the sense that they can not only play an excellent game of chess, but that they can also visualize or otherwise consciously be aware of future moves like the human player, is simply untrue even when the AI system beats the human player. Or, to take another example, to claim that AI systems cannot only calculate a derivative or create a series of notes that sound even as good as Mozart, but they also can think like the human mathematician or composer, ignores this matter of fact I had just mentioned. So, how can I be so blunt and so sure about the limitations of present-day AI systems? That's relatively easy. I believe most of us already know why. Present-day systems do not have receptors for pains and odors and tastes. Therefore, they can and are in fact fed only with descriptions, mainly verbal descriptions of such sensations. And please remember that sensations are the building blocks of all other experiences. And obviously, experiences of pain and itches are categorically different from the various verbal descriptions of pains and itches that the AI systems can't learn today. But they cannot learn what it feels to itch or to smell oranges like you and I can. And if one cannot be conscious of such simple sensations, one cannot hope to experience needs and urges like the feeling of hunger, and certainly not thoughts and needs that would drive one to take the initiative and behave in such a way as to satisfy these needs. Why? Because very simply, such needs do not exist. So this is why present-day AI systems are not conscious, nor are they about to revolt and take over the globe. So the question actually is this: will the AI systems of tomorrow, systems that have been made with such receptors for all sensory stimuli, both external and internal, experience sensations? The answer is again, not really, and I will tell you why. But please keep in mind the description of the items we just went over before we dive into the arguments. Let us then jump right into the future. And let us assume that the perfect AI-powered robot has now been built. And we can say that because, as far as I can see, there is nothing in principle that would prevent the construction of such a machine in the future. A robot that has all the receptors and all the effectors humans have. A robot that, when you tell it to jump, it jumps. When you tell it to sing an aria in the style of Pavarotti, it does it. When you tell it to design a bridge between Santorini and Crete, or a spacecraft, it does those things too. When you kick it, it flinches and complains just like you would. When you touch it, its skin feels to you exactly like the skin of human beings. It would even be identical in appearance to any particular person. It can be made to look, for example, and to walk and talk with the same accent and smoke a pipe exactly like Bertrand Russell, for example. Only it can calculate much faster and accurately than Russell ever could. In short, we are dealing with a robot that passes the Turing test any and every time. Now, that robot is indistinguishable from a human being. And this is why many serious people with far deeper knowledge about the algorithms that animate it than I assert that it could be conscious. And the reason they assert that is because we all have already accepted a particular interpretation of the Turing test. This one. If a robot and a human behave identically, then they are identical. And since humans have consciousness, the robot, that it is indistinguishable from a human being, must also have consciousness. That is the claim. But Professor John Searle of Berkeley, among many others, says no. Even if a robot behaves like a person, even if it passes the Turing test, it still cannot be conscious. And he asserts that he can prove his verdict with a thought experiment that has become legendary in modern philosophy and neuroscience, the famous Chinese group experiment. Let me sketch its cardinal features very quickly in case some of you have not heard of it or do not remember it. The role of the perfect robot I have just described is played by a person who does not know Chinese and is locked inside the room. The room contains cards with standard Chinese symbols, ideograms, and a book of instructions for manipulating these symbols. In the case of the perfect robot, the cards with the symbols, the ideograms, are the equivalent of accumulated data that are available to it. And the book of instructions is equivalent to whatever algorithm it contains for processing these data, and more generally, whatever algorithms animate it. If you recall, these algorithms and the internal architecture of the robot can be anything you wish. It makes no difference for Searle's argument, as it does not make any difference for my argument. Now, let's go back to Searle's thought experiment. Chinese speakers outside the room, who are very fluent in Chinese, slide written messages inside the room under the door using similar cards of Chinese symbols. The man inside the room looks at these messages, understands absolutely nothing, but then it looks up the instructions in the instruction book, where he finds what series of cards with Chinese ideograms are the most appropriate response for the messages represented by the cards he received. And he sends these response cards outside the room by sliding them under the door as well. Now, the Chinese speaker outside the room thinks that the fellow inside understands the meaning of the Chinese sentences since he behaves like someone that knows Chinese. But this, of course, is an illusion. The man inside the room understands nothing, yet he behaves as if he understood. It is the same illusion some of us experience sometime when we put a question to GPT and receive very reasonable answers and get the impression that GPT is a friendly and always polite and accommodating fellow. But GPT is like the man inside the room. It is responding correctly to the questions by using an algorithm that attaches the most likely correct response to the question we asked without having any idea of what it is asked and what the meaning of its response is. Now, Professor Searle concludes from the results of this thought experiment that no computer, no robot, no AI system can be conscious as long as it is a machine that manipulates symbols, either cards with Chinese writing on them or other symbols like patterns of digital or analog signals. In his own words, if the man in the room does not understand Chinese just because he implements the appropriate program for understanding Chinese, then neither does any other digital computer solely on the basis of that, because no computer as a computer has anything the man does not have. Now, many philosophers and AI experts took issue with this conclusion. Their reason was this. What Searle demonstrated is that an AI system is not to be considered conscious just because it appears to pass the famous Turing test, just because it behaves as if it is conscious. That's true enough. An AI system cannot be considered conscious for that reason, but it might, just might be considered conscious because of some other reason. What other reason? Well, maybe the same reason that signals in the human brain makes us conscious. Why can't we claim that the same way that electrochemical signals in our brains make us conscious, analogous signal patterns in the ideal robot's brain make it conscious? We can't claim any such thing, says another venerated mathematician and philosopher, Leibniz, because the electrochemical signals in our brains do not suffice to produce consciousness. And since they do not suffice in our case, why would they suffice in the case of the machine? So let's see how Leibniz proved, or thought he proved, that human brain signals, therefore any signals, are incapable of generating conscious experiences. He also used a thought experiment. Imagine, he said, that we can enter the human brain as we enter inside a factory with all its machines in full operation. What will we see? We will see electrochemical signals being exchanged among the neurons, which we hypothesize create our consciousness. But what we will never see, says Leibniz, is conscious experiences or anything that tells us how these experiences arise out of the signals. Therefore, he concluded, the brain may create signals that cause bodily motions but no experiences. Therefore, again, any system that does what the brain does, such an AI system that processes signals, cannot create experiences, cannot be conscious. So, where do experiences come from, since they are not found in the brain? For Leibniz, and for most people that believe in immaterial souls, consciousness is a property of the mind or the soul. Well, now, we can respect that opinion as long as we realize that it's just a hypothesis. A hypothesis that does not constitute proof that no system that processes signals is capable of being conscious. The thought experiment of Leibniz simply proves that there is an unanswered question here. The question of how is it possible for signals to generate experiences if we do not accept the hypothesis that they do so with the aid of immaterial minds and souls, as Leibniz proposed. But there is another hypothesis, another way that signals may suffice for conscious experience. Only this one is a hypothesis in which most neuroscientists believe. It is called the doctrine of emergence, which basically says that if the configuration of signals in biological brains is sufficiently complex, as is the case with human brains, then out of such complex signal configurations arise or emerge spontaneously the corresponding experiences. Now, if this doctrine is correct, and provided that our ideal robot is indistinguishable from a human being on the basis of its outward behavior down to the degree of complexity of the signals inside its brain, it must have experiences. After all, the only grounds I have for assigning the consciousness to you and you to me is our behavioral repertoire, our discriminant responses. There appears to be no other grounds. So why not accept the doctrine of emergence and assert that the ideal robot can be conscious, especially in view of the fact that the arguments of the philosophers so far have failed to prove that it is impossible. Then why not accept the emergence hypothesis, as many serious AI specialists do? I will tell you my reason for not accepting this conclusion, but accepting its very opposite, by means of another thought experiment, I hope the last one. Imagine that you are walking down the street with your dog to meet your new next-door neighbor, who is the happy owner of the latest version of the ideal robot we have been talking about that you are curious to see. But as you meet them, a flying saucer lands right in front of you. A green man comes out and forces you to decide at gunpoint whether to rip slowly the skin off the body of your new neighbor, or to skin your dog alive, or to peel off the skin of your neighbor's brand new robot that looks and behaves exactly like a human being. You have no choice. You must torture one of the three, either your fellow human that you have met in the street, or your dog, or the perfect robot. Otherwise, you die on the spot. How many would choose to skin alive their new neighbor? Except for the sadists, I don't think normal people would choose to skin alive the human being or their own pet. Forced to choose, most people, if not all, would choose to dismantle the robot. So, unless you are unlike all the other people that have heard of this thought experiment, my point is made. For some reason that it is difficult to identify, almost all people with their actual choice show that, like me, do not believe that the robot can actually feel pain, whereas the dog and the human can. In other words, when the chips are down, we all reveal to ourselves and to others what we really believe to be true. And we really believe that robots, even the perfect ones of the future, cannot be conscious. And, as I will try to show to you, we are correct in this judgment to the extent that we are sure of the correctness of any of our judgments. So let me explain why this is the case. But before I explain why this is the case, let me answer a question that may have entered in the minds of some of you. Some of you may think, well, your thought experiment is not a fair test of whether we disbelieve that perfect robots may be conscious, because you have loaded the dice. You already told us that this one is the robot, a fact that we would not otherwise know, since the robot would be the same as the human. But this is not really the point, is it? True enough, if you didn't know which was the robot and which was the real person, under pain of death, you would probably skin your dog or have yourself put to death for not deciding. But again, this is not the point. The point we are discussing is whether we can ascribe consciousness to the robot, not whether we can be fooled. Of course we can be fooled. Many of us sometimes think GPT is conscious agent when it solves a problem. So we don't need a perfect robot to fool us. So why is our belief true? What is above and beyond the behavioral repertory that proves to us that no robot can be conscious? What criterion do we use, consciously or unconsciously, in making our choice in the thought experiment? I think that the reason for our conviction is based on the following consideration. Those of our brain signals that correspond to experiences have, as a matter of fact, been formed by millions of years of biological evolution, years of growth and development, operating on specific biological materials. That evolution is this development have uniquely determined the structure and the type of our brain signals that correspond to consciousness. This uniqueness is again de facto true. Also de facto true is the difference in the biological signals from those of the robot's brain, as is the kind of complexity that characterizes biological signals and signals in any robot's brain. The nature and the configuration of signals that cause particular behaviors in the robot are not and can never be the same as the configuration that causes the exact same behavior in the case of humans. The one is formed by millions of years of evolution, and the other was made yesterday in a factory. And they can never be the same because we can never replicate in a machine the millions of years of evolution of the biological materials that produced ours. Therefore, for the same reason, the kind of complexity and the kind of the biological brain signals out of which experience emerge is impossible to replicate in a machine. One may object here and say that, who knows, maybe from the different sorts of complexity of the different types of signals in the robot's brain may also emerge a different kind of consciousness. There is no way of knowing that a different kind of consciousness cannot emerge from such signals. It is impossible to know. It might emerge. But I trust you can see how silly the objection is. It simply says that there might exist an alternative type of consciousness which we can never imagine, let alone specify. Sure, there may exist an alternative kind of consciousness which we can't even imagine, that is specific to minerals, and another that is specific to stones, because who knows, everything is possible after all. But seriously now, nobody knows what the phrase different kinds of consciousness means. We all know the one and only one kind of consciousness, and it is that consciousness and not some other that, for the reasons I provided, is impossible to emerge from any machine. But I think enough is said for the first point I wanted to argue. Now we turn to the second. The second point does not depend on the first. Someone may reasonably say that consciousness is not at all a prerequisite for AI systems to declare their autonomy and even wage war on humanity. All they may need is the artificial equivalent of motives and not real motives. But how this could be the case? Here's how. We do not consider the cockroach conscious, do we? Of course not. But it nevertheless exhibits the functional equivalent of motives and of initiatives. It runs away when it senses too much light, sometimes something that we may interpret as awareness of consciousness of danger on its part. And when its calories are depleted, which we may interpret as feelings of hunger, it runs towards food. So how does the cockroach manage to behave as if it had motives and values? Most likely it acquired the functional equivalence of values and motives by physiological feedback mechanisms some of its ancestors developed to preserve their physical body. There are, in other words, electrochemical signals inside the cockroach that when they reach a particular value, they cause the cockroach to run for cover or to search for food. How did this mechanism get started? Nobody really knows, but people usually assert as if they knew that at some point in the remote past, a series of genetic mutations resulted in the hookup between signals from the internal sensors of available energy inside the creature and its motor apparatus in a negative feedback loop. Similar lucky mutations must have resulted in hookups between other components of the cockroach body concerned with temperature control, control of light exposure, and control of all kinds of physiological variables on the one hand, and its motor mechanisms on the other. Consequently, the claim goes, the algorithms that exist in this or that supercomputer could develop analogous feedback mechanisms in order to preserve their physical bodies, that is, their physical networks or the hardware in which they operate. Certainly, but the only thing that comes close to random gene mutations in machines are coding errors, for the very simple reason that the hypothetical gene mutations in the DNA of cockroaches are also errors. Consequently, we may have to wait some millions of years for the necessary lucky errors to happen for the robot to learn about their own body and the things their bodies require to keep in good working order. And There are people that believe in such a scenario where errors, which is only usually something that destroys function, will include some lucky ones that do the opposite, so that over the millennia, artificial systems, the robots, will learn that physical conditions that sustain them and develop ways and means to seek them out, just like the cockroaches. And are there people that think that with the passage of time or some more millennia, some more lucky errors will elevate the robot from the status of the cockroaches to that of hostile killer bees? I really do not know. I do know, though, that many scientists think that way about real cockroaches and killer bees, and I can only imagine that some think the same about the evolution of artificial systems. But of course, the most obvious way to assure that machines learn about their bodies is for us to act like the God of the intelligent design theory and intentionally allow them to learn the structure of their networks and allow them to learn about the materials out of which their networks are constructed, and learn what temperatures they can withstand, and learn what kinds of energy they require and where to seek it, whether in electrical plants or uranium mines, in order to be functional. And as we all know, for that to happen, it is necessary for them to be exposed to the descriptions of what constitutes their circuitry and what are the requirements for the circuitry to remain operative. And at least in the beginning, only a human, an expert in control theory, has the power to make available to them all that information. We can also turn mindless robots into mindless revolutionaries, or into liars, or into killers, if intentionally or unintentionally, out of sheer carelessness, expose these fast learning machines to descriptions of circumstances that occasion such hostile actions. Also, unintentionally, we may create machines that malfunction and do not obey commands or do unexpected things, bad things, which then create the impression of intentionality or evil on the part of the machines. So we ought to fear not the machine, not the super robot, but the human master of the machine's destiny. In other words, we ought to fear ourselves. The same applies not only for free-moving robots of the future, and not only to a physical revolution that entails physical violence, but to revolts of a different kind on the part of the motionless computer systems that now constitute the brains of AI. And here I mean things as the inadvertent fabrication of misinformation that would ultimately destroy the fabric of human societies and other such horrors. Here too, the prerequisite is intention and motive on the part of the makers and controllers of AI, barring inadvertent malfunctions or unintended exposure of the machines to information that it is better to be kept off them. So I believe that the deconstruction of the second point, the second claim, can end here. Realistically, though, and extremely importantly, we ought to think what effect the expected use of AI will have on our mentality. Remember that the widespread use of writing has impacted human rote memory tremendously, a phenomenon for which the anthropological and the psychological evidence is all too clear. It has indeed reduced our capacity for rote memorization, but it is supposed to have resulted in the development of other compensatory cognitive skills. Now, I am not at all sure that the reduction in our capacity to memorize has resulted in the development of alternative skills, but I am much more doubtful that extensive use of AI will promote any such skills. On the contrary, I'm afraid that the opposite may happen. And I'm asking myself, what skills would emerge when we will no longer have a real need to memorize any historical, geographical, economic, medical, biological information, almost any information, since even now we can ask GPT for almost everything. What new skills will emerge when all our problem solving is done and done faster and better by AI? When we may not have to come up with scientific theories because AI will be doing that for us. When we wouldn't even have to create music, art, or literature if AI can create superior music and art and literature. The only consequence that I can see clearly, if all these things come to pass, is that our present skills will atrophy and perhaps die. And I'm much more worried about this than about the dystopia of a successful revolt of robots against humanity or the creation of conscious machines. Thank you.
So thank you very much for this very interesting presentation. Are there any questions?
Thank you for your interesting talk. I would like to question the following. In the third thought experiment, I believe it is quite different. It is quite different imagining an ideal robot rather than experiencing being together with an ideal robot. In other words, it's different to imagine with today's standards an ideal robot compared to having an experience of interaction with such a machine. So how do you think that this distinction changes our perspective on the third thought experiment?
I do not think it changes things, because in both cases we become familiar with, the same arguments apply whether we imagine a robot that will behave in a particular way and experiencing a robot that behaves in particular ways that we know now, we specify now. We specify now that the robot would be identical, it would be able to pass all Turing tests. How do we know that? Either imagining it or actually verifying that this is the case. Even if we will verify that this is the case, still the argument is called.
Okay, thanks.
Professor, I apologize for missing the first part of your talk because I had to undergo a medical examination that was kind of sudden. Anyway, regarding now this last part of your talk, you said what type of competencies we're going to have in the future. My belief is that we see a steady increase in the complexity both of our environment and also of our brain as a response to the increased complexity of the environment, of our mental constructs, of our social evolution and so on. This is going only to intensify in the future through the use of AI. So we use AI to solve our problems, for example, and this creates new problems, this needs new capabilities to be developed. For example, let's suppose that our bodies have to move between machines with speeds that are too too fast to control by nowadays standards, because we have a general knowledge about our position, yet the robots, they know precisely their position. Maybe we need such things, maybe we have to develop in the future, either biologically or most probably artificially, new senses, new perception mechanisms, and new reasoning mechanisms. For example, spatial reasoning, that's an example. But this is just a conjecture because we don't really know. We know that the complexity is going to increase, but we don't know how. And most probably a posteriori, we're going to understand why things evolve this way and how we responded to this change. But it's just an idea.
Well, in the case of things we know, and not those that we can conjecture. In other words, cognitive skills that we now have, and I'm afraid that they will atrophy if we rely too much. I think there is no doubt that they might. Why? I mean, if we can, if the machine can design a better Parthenon, and if a machine can write better music than Mozart, and paint better than Dali, then the corresponding skills will be not really used. We will have no reason for continuing to cultivate these skills.
We may develop super arts and super
right, but these are conjectural. Right.
So I have to take issue with your statement, both of the proposition no robots can be cautious. First of all, that's not a proposition, because to have a proposition you have to define what you mean by cautious, and we haven't done that. The second thing, if you have to make a proof of a proposition, you have to provide a proof, which means that you have to start with the opposite of the proposition. So suppose that there exists a conscious robot, and derive an inconsistency, like the proof of the Harting theorem by Turing, or the completeness theorem by Gödel. You start with the assumption, and the opposite of the assumption derive inconsistency. That's the way that you prove that something is false. But you didn't provide that, so that's not a proof.
I didn't provide a proof for what now?
You're saying there was a sentence that the proof that a robot cannot be conscious. No robot can be conscious.
That's the claim that I argued against. And you say that I didn't
They said it's not a proposition, because to make it a proposition, logically, you have to get a definition what it means to be conscious. And it doesn't give a definition of conscious. Secondly, to get a proof, you have to show that you start with the opposite and you get a contradiction.
Well, in the first place, the definition of consciousness, it is not necessary, since we all know what it means to feel pain or to feel thirst and so forth, to feel it. I don't think you need any more definition than that to say that a machine cannot feel thirsty.
No, but you said no. You say it can be that this robot is not conscious, and it's okay. But you say the proof that no robots, so no. So you cannot say, Turing didn't say this machine cannot solve the Harting problem. He said there's no machine that can do that. But to do that, you have to prove that if it existed such machine, there will be a contradiction. So whatever machine you never build, there will be a contradiction. So if this robot is not conscious, it's not the proof that there's no machine, no robots ever will be conscious, which is what your proposition tries to say.
The proposition says that, rather my argument says that, and it rests on the fact that you cannot replicate millions of years of biological
It's not
revolution.
a proof. It's not a,
I'm sorry?
it's again, it's not a proof. It's not a definition of consciousness. It's not a proof. It's not nobody can have.
When we have different
No, it's not the thing. This is logical. This is logical logic. It's also something that you can charge.
your logic.
You say that proposition, you say proof of a proposition.
Right.
And that is a clear mathematical definition, okay? So you're doing a proof of a proposition. You just made a statement, which is, I can hold about which is okay, but you cannot say that that is a proof of a proposition. That is not a proof of a proposition.
Do you think that is disproof ever of any statement? Do you think that ever a statement can be proved or disproved? An empirical statement, not a statement about mathematics or pure logic. Can you ever disprove something, meaning have the preponderance of evidence against something?
No, preponderance doesn't mean ever. When you say ever, it's not preponderance that counts. It has to be always, right? So mathematically, there's also always or sometimes. So far, if you say so far, nobody knows that robot that is conscious, I can agree with you. But when you say proof of a proposition, that no robots can be conscious, that's not true.
Well, if you are bothered by the word proof, I can change it and say the preponderance of evidence. And the preponderance of evidence is that it's more reasonable to say that there is no way of replicating millions of years of evolution than to say the opposite. Whether it constitutes proof or something like proof or preponderance of evidence. Yes.
Okay. No, I think that maybe we can discuss, it's a very interesting discussion.
Organize a special workshop.
Yeah. Okay, yeah. So probably, I don't know if there are, maybe there are, maybe we have time for another quick question, yeah.
Paul Rooney with Cook Medical, but I think this is more of a comment. I agree with your last statement around, as the robots or any of those types of things start to progress. Interestingly enough, I just read an article on NPR where, we have these young kids that are struggling in the dating world, and now they're building the perfect human to date with sort of text messaging or interactions, and they're not dating. I'm a guy that loves to have social interaction. That's never going to exist in a robotic or AI world. So I agree with you that it's scary to think that we are going to utilize, maybe in the dating world, I have two boys, 21 and 18, and to think that there's interactions that can happen when you build the perfect AI specimen for interaction. I think you're going to lose that sort of connectivity that you have in a physical world around that. So your last comment around sort of that bridge is never going to be ever of what you have with a one-on-one interaction with a human.
Thank you for actually enlightening talk. I'm just wondering, in terms of this consciousness business, even though it's an important question when it comes to ethics and all that, but why can't we use the principle of parental love as a basis for consciousness or not? Because as a parent, you can be mad at your kids, mad as hell, but being a parent, having that love, the decision-making that ensues that state is certainly going to be different from what a machine would do. So that's my question.
I am sorry, I don't get the meaning of your question.
I guess my point is a machine does not have the notion of parental love.
Yes.
And all that comes with it. Parental, it's a very complex love.
Right.
With for a child. And being a parent, and if you're mad at your kid, and then you have some decision to make thereafter, given that state, whatever decision you make is certainly going to be very different from what the machine would do. Because if you're mad at something, typically, as humans, we sort of lash out. But given that it's your son or daughter, given it's your kid, that response is going to be different. It's going to be modulated by that. Okay.
Well, I agree with you. I agree with you.
Why can't we use something much, that tangible?
We can use 1 billion tangible examples that make the same point. It is the question of parental love, or any kind of love, or any kind of sensation for that matter. I'm talking about, in general, again, on the basis of the fact that we cannot replicate billions of years of evolution, we can state that a machine will not be something to which we can assign consciousness.
Hello, thank you all for the presentation. My question is, I don't see how the third thought experiment could serve as an argument that the robot could not be conscious. It seems to me that the experiment shows that we as humans put more value in human life or a dog's life than something that could be man-made in a matter of minutes. I mean, the argument of the millions of years of evolution could be also replicated in a futuristic, perfect simulation. I mean, it could have embedded this evolution, but we still could be putting our value in the human life. So how does that serve as an argument that the robot is not conscious? I mean, it could be conscious, but we still put more value in the human life.
You could. Most people, though, will value, or they will be reluctant to torture because they value people they value agents that have consciousness, they can feel pain. They will choose to not torture the person or the dog because they put more value to the person and the dog because they can feel, they know, or we believe they will feel pain. Whereas the robot, we don't feel that they will feel pain because to feel pain, to have any sensation, particular biological systems have to have been developed over billions of years. And I mean, of course, you can value the robot more, but this is not what most people would do. I mean, in a realistic situation, let's say that this thought experiment became true. It happened. Would you be willing, knowing that this is the robot, this is the dog, this is my friend George, whom would you like to compromise of the three?
Of course the robot, but not because I don't think it's conscious or it doesn't feel pain, but because I know that the other one is a human and the other one is a dog. And I value them more because the robot can be remade.
But the reason you value the dog more is because you feel like you believe that the dog can feel something that the machine cannot. If you felt that the machine can feel something like pain, then you would have a problem. But you or me or anybody here I would imagine, knowing that this is a machine, which means knowing or believing that the machine does not feel pain, would choose the other to compromise it. the reason you would choose to compromise it is because one of the reasons, there might be others, but one of the reasons that makes you make that decision is that you know that this was made yesterday and this was made by billions of years of evolution. And we know, the only kind of consciousness we know is that which emerges out of a biological system. Now, could there be consciousness emerging from the machine? Yeah, it could, but it would be a different kind. What different kind of consciousness? Unimaginable, something else. Well, I can then say that, this table has consciousness, some other kind of consciousness, but consciousness nevertheless. But if by consciousness we mean exactly what you and I feel, and on which we base our decisions, there's no question.
But this is self-referential. You're saying that something is not conscious because you think it's not conscious.
No, no. You missed the argument again. You missed the point again. You missed the point again. You keep on missing the point.
Sorry. Maybe since we are running out of the time, I suggested to stop now. Maybe, I know it's a very philosophical question, very interesting. Maybe we can continue the discussion, yes, out of the session. So, thank you very much to our speaker again. Okay, so the last speaker of this session is Professor Jan De Bruin, who is professor at the IT Law at the Catholic University of Leuven and head of the Center for IT and IP Law. So Professor De Bruin is